Solar farms and rooftop installations are increasing rapidly in the UAE, and even though installation is relatively easy, operations and maintenance is very tough and often very neglected part of solar farms. If it is neglected, which it usually is, then the expenditure on an ongoing basis really increases and the cost of energy goes up. Inspection and repair of defective cells can vary from a few days to a few weeks depending on what the farm size is.
The United Arab Emirates is rapidly becoming a global provider of renewable energy solutions, bearing examples such as Science One, the world's largest concentrated solar power plant, and partnering with New Zealand to boost solar power in Solomon Islands. Being an inexhaustible source of energy, this serves as a barrier to environmental degradation. The substantial increase in renewable energy consumption has led to a proportional rise in the demand and implementation of sources such as solar farms. This works closely with the energy conservation initiatives propagated by the UAE.
So, as the frequency of these inspections tend to be less, the number of possible failures increases. Maintenance or testing during the day while the system is loaded results in losing energy, as said panel is said to be discounted from the grid. So these solar farms are mostly located in the middle of the desert, and it's tough to do operations over there. It's physically taxing, it's strenuous, and it's very resource intensive. So there is a clear issue in managing the operations and maintenance of these solar plants.
Our solution to these problems is the introduction of unmanned aerial vehicles in the inspection process of solar panels in solar farms.
On the hardware side of things, we would use HMFU 580 Pro frame and Pixoc autopilot system to make the solution cost effective. Further, the frame would be customized using in-house 3D printed components to suit the application's needs.
The drone would take off from the control station and then move along a pre-planned path using the GPS waypoint navigation to cover all the panels and then return home.
Our payload consists primarily of a thermal imaging camera and a secondary RGB camera to capture the images required for processing.
The thermal images would be geotagged and stored on board, and further analyzed off-board for hotspots. Now, depending upon the nature of these hotspots, various faults such as diode failures and cracks can be detected, thus making the whole inspection process far more economical and feasible in comparison to the conventional methods used.
Our method proposes to eventually result in lower maintenance and only take in regard minor running costs and simple procedures such as training the staff to operate the drone. Implementation of UAV would translate to a substantial replacement of manpower with a more effective and efficient technology. This will also increase inspection rates, which will eventually result in a huge power output, as the solar panels can be easily maintained during the night after collecting the data.